Okay, greetings. This can be a little bit nasty. You need to simplify. Now remember from the last lesson, you can't have a square root in the denominator. You can't simplify this when there's a square root in the denominator. Now I want to start with this problem right here. I'll come back up to this one, but I'm going to start with this one. So what we have is 5 divided by 3 plus the square root of 2. So remember, you don't want an irrational square root in the denominator. Now I've written this here because I want to show you something, okay? You can write it or just watch. Now a lot of people will just do what we said yesterday and say, well, I don't want the square root of 2, okay? So I'll just multiply by the square root of 2. Well, here's a problem with that, okay? So you take 5 times the square root of 2 from the top, and then that's a whole number and a square root, so we wouldn't multiply that. So that would just be stay equal to 5 times the square root of 2. Okay? So that's your top. Now here's a problem on the bottom. You have to, when you multiply this, you would have to take both 3 times the square root of 2. Okay? And you would have to take the square root of 2 times the square root of 2. Now the square root of 2 times the square root of 2 is 2. We know that, and then we can't times these. Okay, that's 3 times the square root of 2. So then on the bottom, these are not like terms, so you would have 3 times the square root of 2 plus 2. So that solved nothing. And the reason why that is because you got the square root of 2. Well, the square root of 2 times the square root of 2 is the square root of 4, which is 2, so that was good. But then 3 times the square root of 2, we still have the square root in the denominator, so that solved absolutely nothing. Okay? So that's why you're not going to be able to just multiply by the square root number. What you're going to employ is when you have this, when you have a plus, I should say, a plus or a minus. It could be either way, okay? We'll just call it a plus. You want to put that in parentheses, and then you want to write the word conjugate. You're going to multiply by a fraction, but here's how you make this into the conjugate, okay? You're going to put a parentheses, and you're going to put the 3, okay? 3. The 3 stays the same, and then plus, but then that square root of 2 we're going to turn into a negative. It's positive over here, so we're going to make it negative over here. So you keep the first term exactly the same, okay? You write your plus sign, and then you want to turn this second term from a positive to a negative. So negative square root of 2. Okay, and that's also what I need to put on the top. Remember, I need to multiply the same thing on top that I'm multiplying on the bottom. 3 plus negative square root of 2. So again, it's not that hard. You just keep the first term the same, okay? When there's 2 separate terms, okay, like this is, you keep the first term the same, then your plus sign, then switch your positive to a negative. And that's going to get the square root out from underneath the bottom. Now, you got to be careful when you're multiplying here. See, first off, you want your, on top, let's just talk about what's going to happen on top. 5 times quantity 3 plus negative square root of 2. First thing you want to do is put a 1 in front of that square root, so then I know what the heck I'm distributing. So 5 to 3 and 5 to negative 1. So I'm going to write 5 right there. And I'm going to take it times the 3 and take it times the negative 1 with its square root of 2. So 5 times 3, then 5 times negative 1 times the square root of 2. Let me figure those out. Okay. So this is 15, and then 5 times negative 1 is negative 5 times the square root of 2. Now just leave that for a moment. Okay, just leave that. Now, let's kind of split that down the middle. Now let's multiply on the bottom. So the bottom, you want 1 coefficients in front of your square root. Okay. So put 1s. So you take 3 to 3 and then 3 to negative 1. So 3 times the 3 and then times the negative 1 times the square root of 2. That's a 3. Now we do the 1. That's a positive 1 to 3, positive 1 to negative 1. So 1 times the square root of 2, I should say. because that 1 is times by the square root of 2, then we multiply it by the same thing. So 3 and the negative 1 times the square root of 2. Now you find those. So you got 9, negative 3 times the square root of 2. 1 times 3 is 3. You multiply the whole numbers, multiply the square roots. 1 times negative 1 is negative 1. And then the square root of 2 times the square root of 2 is the square root of 4. Okay. Now, put your 15, put your negative 5 times your square root of 2, and then down in this square here, put your 9, put your negative 3 times the square root of 2, put your positive 3 times the square root of 2, and put your negative 1 times the square root of 4. Now make your fraction here, and you're going to simplify these. This is the top, this is the bottom. 5 times 3, 5 times negative. Now see if they'll simplify. Well, 15 is a whole number. It's not going to be able to be simplified. Now the square root of 2 is irrational. Okay? So you put in the division sign, but the only thing 2 is going to divide by is 1, so then that's already done. So then we have our whole number value 15 plus the negative 5, but the negative 5 is multiplied by the square root of 2, so we can't add the 15 to the negative 5. This is multiplied by the square root of 2. This is multiplied by nothing. So we put 15 plus negative 5 times the square root of 2. Now we're looking for the bottom. That's where I did this, all this stuff right here. So you have 9. That's simplified. Now look at these two. This is what happens when you multiply conjugates. The middle two cancel out because they're both the square root of 2, but a negative 3 plus a 3 is 0. So it'd be 0 times the square root of 2, which cancels that out. We don't worry about that. Now the square root of 4 is not irrational. That's equal to 2. So it's negative 1 times 2, and that's negative 2. Now we need to add 9 and negative 2 because they're both whole numbers. 9 plus negative 2 is 7. Okay? So put 7, and there's your simplified answer. Okay? Now you're like, what do I divide? Well, nothing, and here's why. The square root you don't divide. Okay? If you divide 15 by 7, that's a pretty crappy looking decimal. Okay? If you divide the negative 5 by the 7, that's a pretty crappy looking decimal. So since they're both crappy looking decimals, we just leave that. That's going to be the form we leave that in when we use the conjugate method. Okay, next one, we got 9 divided by 2, and you make that plus negative, and you might as well put the 1 right now. Negative 1 times the square root of 7. So this is a plus, so it goes in parentheses. And that means to get the square root out of the denominator, we have to use the conjugate method. So you make a parentheses, leave the 2 the same, put the plus, but now instead of negative 1, we need positive 1 times the square root of 3. Okay? So if it's negative here, the conjugate's got to be positive. If the original is positive, then the conjugate's negative. Okay? Then up here we're going to put the same thing. Okay? Now you just do exactly what you were doing before. Okay? So I'm going to kind of split this up. So on top we're going to take 9 to 2, 9 to 1. So 9 is what we're distributing, times 2, and then times 1 times the square root of 3. Okay, so this is 18, and this is 9 times the square root of 3. Now down on the bottom, we have to do the FOIL. Okay, we do 2 to 2, 2 to 1. So 2, 2, times 2, times 1 times the square root of 3. Okay? Then negative 1 to 2 and negative 1 to 1. But negative 1 is times the square root of 3. Okay? Then times 2 times 1 times the square root of 3. Okay, so 2 times 2 equals 4. 2 times 1 is 2 times the square root of 3. Negative 1 times 2 is negative 2 times the square root of 3. Negative 1 times 1 is negative 1 times the square root of 9. Now we try to simplify these. So on top, we've got 18 and we've got 9 times the square root of 3. Now 18 can't be simplified. and the square root of 3 is irrational, but if you put in the division sign, the only thing 3 is divisible by is 1. Okay, so that's in simplest form. So we have the whole number 18 plus 9 times the square root of 3. Now remember, the 18 and the 9 can't be added because the 18 is not multiplied by the square root of 3, the 9 is. So we put 18 plus 9 times square root of 3. Now, let's look at the bottom. We got 4. We got 2 times the square root of 3. We have negative 2 times the square root of 3. We have negative 1 times the square root of 9. So that's a whole number. And remember, these cancel. They're the same thing. They're just positive and negative. So if they're both multiplied by the square root of 3, but they're the opposites. And that's why the conjugate method works the way that it does. Then you have negative 1 times the square root of 9 is rational. It's not irrational. It's 3. Okay? So negative 1 times 3 is negative 3. Okay? And then I add the 4 and the negative 3, and that's going to be 1. Okay? And you can circle that. Technically, if you end up with 1, you don't need anything on the bottom. It could just be 18, or 18 plus 9 times the square root of 3. If you end up with 1, you can just ignore the bottom because 4 plus negative 3 is 1. Again, you add those. Okay, let's keep this rolling. This is kind of a pain, I'm not going to lie. Okay, so we see the plus sign. And, of course, what we're going to do then, you use the conjugate method. You keep the 6 the same, you put the plus sign, and then you switch that from the positive square root of 5 to negative square root of 5. And then we're going to put the same thing on top, 6 plus negative square root of 5. Now you need to apply 1s in front of each of your square roots. I think that really helps, is if you put if you don't have a multiplying number, you automatically put a 1. So 1, negative 1, 1, and negative 1. Okay, so now I find the top. Okay, remember I got to find the top and the bottom. I'll simplify them over here. Okay. So 1 to 6, 1 to negative 1, but the 1 is multiplied by the square root of 5. So when I'm writing that down, I got to remember that. Okay. And then 6 isn't multiplied, and then the negative 1's multiplied by the square root of 5. Okay, 1 times 6 is 6 times the square root of 5. 1 times negative 1 is negative 1, and then the square root of 5 times the square root of 5 is a square root of 25. We know that's going to turn into just regular 5 in a bit here. Okay. Now on bottom you have to use the FOIL because you have a 6 and a 1 you have to distribute. So 6 to 6, 6 to negative 1. So 6 times 6 is what I'm distributing. The 6 there is not multiplied by a square root. So we're going to multiply it by 6, and then we're going to multiply it by negative 1 times the square root of 5. Okay. Then that'll be the end of the 6, but then the 1 times the square root of 5 has to be distributed to 6 and to the same two things. So 1 times the square root of 5. Then times 6 times the same two things. Negative 1 times the square root of 5. So 6 times 6 is 36. 6 times negative 1 is negative 6 times the square root of 5. 1 times 6 is 6 times the square root of 5. 1 times negative 1 is negative 1 times the square root of 25. Now simplify these, okay? So on top we got 6 times the square root of 5 and negative 1 times the square root of 25. So the square root of 5 is irrational, okay? But the only thing 5 is going to be divisible by, you can put in the division sign, but I think the only thing that goes into 5 as far as perfect squares go is 1, okay? So 5 divided by 4 is a decimal, okay? 5 divided by, so it's just 1. So this is in simplest form already. Now the square root of 25 is not irrational, it equals 5. So we have negative 1 times 5, and that equals negative 5. So again, we have a 6 times the square root of 5, and then a negative 5 whole. It's not really a whole, it's called an integer, but Okay, we don't add those because when one's multiplied by the square root of 5 and the other's not multiplied, we can't add them. So on top we put 6 times the square root of 5 plus negative 5. Now the bottom you got 36, and you know that the middle two are going to be exactly the same except they are opposites, conjugates. Okay, so we know that these two cancel. Okay, I mean they're both square root of 5, and then the negative 6 plus they're both the same. They're both opposite coefficients. So that's a whole number, and this of course is not irrational. The square root of 25 equals 5. So negative 1 times 5 is negative 5. So now we have 36 and negative 5, and those can be added. They're like terms. Neither one of them is multiplied by a square root. So 36 plus negative 5 is 31. So there's your denominator. Now 6 divided by 31 is a crazy decimal, so is negative 5 divided by 31, so that's your answer right there. Okay, now make that plus negative. I always like to have the plus, and then I'll put a 1. I know I'm going to, and then a times. Okay, so again, I put that in parentheses when I have an addition of two separate terms. Okay, we employ the conjugate to get rid of the square root. Okay. So we're going to have the square root of 3 on top, and then conjugate, you keep that a 3. You put plus, but instead of negative 1 times the square root of 2, it's going to be positive 1 times the square root of 2. And then this is going to be the same thing. Okay, I don't know why I put that. That was stupid. I'm losing it. Okay, don't put that. You put the same thing here. 3 plus 1 times the square root of 2. Okay, so the square root, I would put a whole coefficient in front of it, and then I would multiply it. Okay, so this is where our answer is going to be. Now I multiply the top. So 1 to 3, 1 to 1. So it's going to be 1 times the square root of 3 is what I'm distributing. Now I'm going to multiply that by 3. 3 is not multiplied by anything, and then I'm going to multiply it by 1 times the square root of 2. So 1 times 3 is 3 times the square root of 3. 1 times 1 is 1 times the square root of 6. Okay. Now on the bottom, 3 times you FOIL 3 to 3, 3 to 1 times the square root of 2. So 3 times 3, and then times 1 times the square root of 2. Now we do the negative 1. Times the square root of 2 to 3, negative 1 times the square root of 2 to 1 times the square root of 2. So negative 1 times square root of 2, negative 1 times the square root of 2. So we got 9, 3 times the square root of 2. Oops, I need to write what I'm timesing. Same two things, 3, 1 times the square root of 2. So negative 1 times 3 is negative 3 times the square root of 2. Negative 1 times 1 is negative 1 times the square root of 4. Okay. So on top we got 3 times the square root of 3, and we've got 1 times the square root of 6. Then we got 9, 3 times the square root of 2, negative 3 times the square root of 2, and then negative 1 times the square root of 4. Okay, so square root 3, it's irrational, but the only thing that's going to be divisible by is 1. Okay, so that's simplified. Square root of 6, that's irrational. The only thing, one of these perfect squares that goes into 6 is 1. So circle it. So we got 3 and 1, but that's times the square root of 3. That's times the square root of 6. So we need to keep those separate. And that's what you put on top. Okay, then we know that these two cancel in the middle. The middle two, the conjugates cancel the middles. Okay, so you got 9. The square root of 4 equals 2. So it's negative 1 times 2, and that's negative 2. Okay, so then I'm able to add the 9 to the negative 2, which is 7. Okay, and then 3 divided by 7 is a sloppy decimal, so it's 1 divided by 7. So that's going to be your answer right there. Just leave it as the whole thing in fraction form. Okay. Now this looks different, but it's the same thing. It's the exact same concept. make that plus negative, put a 1 there, okay, times. And then, of course, you apply the conjugate, where you put that in parentheses. You keep the square root of 11 the same. You put your plus, but instead of negative 1 times the square root of 7, it's going to be 1 times the square root of 7. Then I put the same thing here. The square root of 11 plus 1 times the square root of 7. Okay, now we need to multiply. Put one multipliers of 1 in front of all your square roots before you multiply. So 11 to 1 times the square root of 11, and then 11 to 1 times the square root of 7. So the 11 whole is what you're distributing. Okay, so 11 times 1 is 11 times the square root of 11. 11 times 1 is 11, but that one's times the square root of 7. Okay. Now down on the bottom, put 1's in. Okay, so you can see what you're multiplying. 1 times 1, so now they all got 1. So I go 1 times the square root of 11 times 1 times the square root of 11. And 1 times the square root of 11 times 1 times the square root of 7. So you got 1 times the square root of 11. That's what you're distributing. You're going to multiply it by the other 1 times the square root of 11, and then 1 times the square root of 7. Okay, then negative 1 with times the square root of 7 times 1 times the square root of 11, then 1 times the square root of 7. Okay, so 1 times 1 is 1. The square root of 11 times the square root of 11 is the square root of 121. And 1 times 1 is 1. The square root of 11 times the square root of 7 is the square root of 77. That's going to be negative 1. The square root of 7 times the square root of 11 is the square root of 77. Negative 1 times 1 is going to be negative 1. And then the square root of 7 times the square root of 7 is the square root of 49. Okay? So on top we got 11 times the square root of 11, and we got 11 times the square root of 7. Okay, the square root of 11 is irrational, but the only thing that goes into 11 is 1. Okay, I mean 9 doesn't go into it, so that takes you to 1, and that's going to be simplified. Square root of 7 is the same thing. The same thing happens. Okay, so 7 divided by 4 doesn't work, so it's just 1. And then these two are separate because we have 11, 11, but that's multiplied by the square root of 11. That one's multiplied by the square root of 7, so those are not like terms. Okay, now let's see what happens on the bottom. Okay, 1 times the square root of 121, 1 times the square root of 77, negative 1 times the square root of 77, and then negative 1 times the square root of 49. Okay, so 121 is not irrational. 121 is equal to, the square root of 121 is 11. Okay, so 1 times 11, and that's 11 whole. These cancel. The square root of 49 is equal to 7. So it's negative 1 times 7, and that's negative 7. And you just add those, and it's 4. Okay, so you have 4 here on the bottom. There you have it. Okay, next one. You see that plus or minus, you make it plus negative, but if it's a plus, you use the conjugate method to get rid of the square roots from out underneath the bottom. So the square root of 3, well, that's going to stay the square root of 3. Then I put the plus, but then that square root of 10 goes from, it can't be the same thing. Remember, a conjugate's not the same. These do not match. This is the matches this, then the plus is, then you switch the second term from positive to negative or negative to positive. This is positive, so I will put a negative. And the square root of 3 plus negative square root of 10. Okay? Alright, so here's my answer. Now top and bottom. So remember, with the square roots, you want multiplying numbers in front. So 1 times, 1 times. Okay. So 1 times the square root of 5 times 1 times the square root of 3, then 1 times the square root of 5 times negative 1 times the square root of 10. So just two distributions, 1 times the square root of 3, and then negative 1 times the square root of 10. Okay, so that's going to be 1, and then the square root of 5 times the square root of 3 is the square root of 15. 1 times negative 1 is negative 1. The square root of 5 times the square root of 10 is the square root of 50. So that's on top. Then on the bottom, put the 1's in so you're not all confused about what you can actually multiply. 1, 1. Okay? So 1 times the square root of 3 times 1 times the square root of 3. Then 1 times the square root of 3 times negative 1 times the square root of 10. So 1 times the square root of 3, negative 1 times the square root of 10. And then 1 times the square, that's done. Then 1 times the square root of 10 times 1 times the square root of 3. Then 1 times the square root of 10 times negative 1 times the square root of 10. Okay, so 1 times 1 is 1. The square root of 3 times the square root of 3 is the square root of 9. 1 times negative 1 is negative 1. The square root of 3 times the square root of 10 is the square root of 30. 1 times 1 is 1. The square root of 10 times the square root of 3 is the square root of 30. 1 times negative 1 is negative 1. The square root of 10 times the square root of 10 is the square root of 100. Okay. Okay, so on top we got 1 times the square root of 15, and then negative 1 times the square root of 50. Now, the square root of 15 is irrational, so divide. So 15 divided by 9, decimal, divisible by 4, no. So it's just 1, which means that's in simplest form. Now 50 is irrational, but this one divides by something other than 1. So 49 doesn't go into 50, 36 doesn't go into 50, but 25 does. Okay, so we drop the negative 1, and we need to rewrite that in our two square roots, 25 and 2. Okay, so the square root of 25 equals 5. So instead of negative 1 times the square root of 50, it's negative 1 times 5 times the square root of 2. So that's going to be negative 5 times the square root of 2. Now, these square roots still don't match, so we still write them separately with the plus sign. Okay. So on top, 1 times the square root of 15 plus negative 5 times the square root of 2. Now, in the bottom right here, 1 times the square root of 9, negative 1 times the square root of 30, 1 times the square root of 30, negative 1 times the square root of 100. Okay? So the square root of 9 turns into 3. Okay? That's rational, not irrational. So 1 times 3 is 3. These two we don't waste time with because they're conjugates. They cancel out. And the square root of 100 is 10. So negative 1 times 10 is negative 10. And of course that allows us to add here. 3 plus negative 10 is negative 7. There we have it. Okay. Technically you're not supposed to have a negative. Well, just don't. Yeah, just... Okay, same thing. Put that plus in parentheses. Then you use the conjugate, and that will get the square roots from out underneath the bottom. Okay? So we keep the square root of 2 the same, plus, but we make the square root of 3 from positive square root of 3 to negative square root of 3. Okay? And we put that same expression on top. Square root of 3 plus negative, square root of 2 plus negative square root of 3. Okay, answer will go here. Put the 1's in front of your square roots. Okay, so 8 to 1 times the square root of 2. then it's going to be 8 again times negative 1 times the square root of 3. So it's 8 times the square root of 2, and that's negative 8 times the square root of 3. Okay, now on bottom 1, 1. Fit the 1 in there. You can do it. Okay, remember that's a negative 1 there. So 1 times the square root of 2 times 1 times the square root of 2. 1 times the square root of 2 times negative 1 times the square root of 3. That's the end of that. Then 1 times the square root of 3 times 1 times the square root of 2. Then 1 times the square root of 3 times negative 1 times the square root of 3. So this is 1 times the square root of 4. This is negative 1 times the square root of 6. This is positive 1 times the square root of 6. And this is negative 1 times the square root of 9. Okay? So on top we got 8 times the square root of 2 and negative 8 times the square root of 3. Square root of 2 is irrational, but the only thing that goes into 2 from this list is 1. Okay, so, and that's the same with the 3 too. But these cannot, nothing can be combined because this 8 here is multiplied by the square root of 2. This negative 8 is multiplied by the square root of 3. So no, they don't cancel. Okay, yeah, you have an 8 and a negative 8, but they're not multiplied by the same square root. So you keep those separate. 8 times the square root of 2 plus negative 8 times the square root of 3. Okay, now on the bottom, 1 times the square root of 4, negative 1 times the square root of 6, 1 times the square root of 6, and then negative 1 times the square root of 9. Okay, remember, these two we know cancel. Okay, doesn't matter what happens, they're the same. They're like terms. Negative 1, positive 1, they're both multiplied by the same square root. Square root of 4 is 2. 1 times 2 then is 2. And over here, 9, those aren't irrational, so that's 3. Negative 1 times 3 is negative 3. Then 2 plus negative 3 is added together because neither one of those is multiplied by a square root. They're like terms. That's negative 1. Some of you are like, do we have to put the 1? Well, it's negative 1, so you should put it. The only way you wouldn't have to put it there is if you made that positive 1, then the 8s would change to opposite. Negative 8, positive 8. But don't worry about that. Okay? Okay, now the next one, remember, now you got 2 parentheses now because there's 2 plus signs, but you just are concerned the conjugate is applied, you just go at the bottom. Okay? So you keep that square root of 7. Put the plus, but that square root of 2 goes from positive to negative. And then you do not conjugate the top, just the bottom. And then you just put the, remember, this fraction here has to be equal to 1, meaning the numerator and denominator have to be exactly the same. Okay, and then it's the same thing. It's just a little bit longer. 1 times, 1 times, 1 times. So 1 times the square root of 7 times 1 times the square root of 7. Then 1 times the square root of 7 times negative 1 times the square root of 2. That's the end of that. Then 1 whole times 1 times the square root of 7. Then 1 whole times negative 1 times the square root of 2. 1 times 1 is 1, and then the square root of 49. Gives us 7s. 1 times negative 1 is negative 1. The square root of 7 times the square root of 2 is the square root of 14. 1 times 1 is 1, and just the square root of 7. 1 times negative 1 is negative 1, and then the square root of 2. Okay. All right, now the bottoms. 1, 1, 1, and 1. So 1 times the square root of 7 times 1 times the square root of 7, then 1 times the square root of 7 times negative 1 times the square root of 2. 1 times the square root of 2 times 1 times the square root of 7, and 1 times the square root of 2 times negative 1 times the square root of 2. So this is 1 times the square root of 49. This is negative 1 times the square root of 14. That's positive 1 times the square root of 14. That's negative 1. Square root of 2 times the square root of 2 is the square root of 4. Okay. So top 1 times the square root of 49, negative 1 times the square root of 14, 1 times the square root of 7, and negative 1 times the square root of 2. Now the square root of 49 is not irrational. That equals 7. Okay, so 1 times 7 is 7 whole. Square root of 14 is irrational, so I put in the division sign. Now what goes into 14? Nope, not 9, not 4, so it's just 1, which means it's already in simplest form. And 7 is the same thing. 4 doesn't go into 7, neither, so it would just be 1. And then 2 is the same thing, okay? Irrational. Alright, so you got 7. That's the only constant you have. That's the only thing that's not multiplied by square root. Then you got the square root of 14, and that's the only square root of 14 you have. So it's negative 1 square root of 14. Then we got the square root of 7, but that's the only square root of 7 I have, so then 1. Then the square root of 2, which is the only one of those I have, so negative 1. So yeah, that's my whole top. 7 plus negative 1 times the square root of 14, plus 1 times the square root of 7, plus negative 1 times the square root of 2. Okay, now on the bottom we got 1 times the square root of 49, negative 1 times the square root of 14, positive 1 times the square root of 14, and then negative 1 times the square root of 4. Okay, well we know that these cancel. That's the whole point of doing this, so that the middle two cancel when I'm finding the bottom product. Okay, so the square root of 49 is 7, so 1 times 7 is 7. And the square root of 4 is equal to 2. See, these are not irrational square roots. Negative 1 times 2 is negative 2. We add those together, 7 plus negative 2 gives you 5. That's your answer, all that over 5.